So consider an experiment in which a colony of live bacteria is introduced to a limited food supply. Suppose the rate of change in the number n of live bacteria with respect to time is given by this. Find the size of the population at time t if initially 1,000 bacteria were introduced to the food supply. So what they're given is a derivative. What they're asking for is nt. Find the size nt. So the job we have is to integrate this function. After we integrate, there will be a number c that we add to the integral. And then we use the given 1,000 there. So let's see what we're talking about. So we have d, dn, dt to be equal to 6,000 t squared minus 75 t4. 6,000 t squared minus 75 t4. So we'll have to integrate this on this side with respect to dt. So it will remain nt on the left. On the right, it will be 6,000. Remember, to integrate to the power, you add the 1 and divide by the sum. 75 t 4 plus 1 over 4 plus 1 plus the constant c. Then from there, we'll have 6,000 t3 divided by 3. Minus 75 t5 divided by 5 plus c. So then the 3 here, 1, 3 there, 2. 5 here, 1, 5 there. It's what? 15. So we'll have 2,000 T3 minus 15 T5 plus C. Like that. Okay. Oh. And then the question reads, so that's the integral. But the question says, find nt of the population at time t if initially 1,000 bacteria were introduced. So initially means before t comes in. So initially means before time starts ticking. So where there is t in the initial statement, you put a 0. So we'll have 2,000 0 power 3 minus 15 0 power 5 plus c. But from there, but we are told that this is 1,000, the initial. This is 0, that is 0. So we get c to be 1,000. So the size of nt is given by 2,000 t power 3 minus 15 t5 plus 1,000. Our job was to find C after we integrated. So that's what we call the application of integral. And the other one we did yesterday for finding the area. It's also the application for integral.
Mr. Keith, did you say yesterday? Okay. Anyway, I have a question. How do you know you need to apply integration to such equation
Okay.
or differentiation?
So the question is saying dn dt. Then they are saying find nt. So for it to be dn dt, it means the nt was differentiated to get dn. So if I want nt, which was differentiated, I must then integrate. So that's how I know that, oh, I'll have to integrate it. You see that?
Could you repeat that, please?
So in the statement, the equation given is the equation dn dt, meaning the derivative of n with respect to t. In the question says find the size nt, meaning find nt.
Okay, thank you.
Okay. So the next question is 6 part C. Consider a function f defined by f of x is equal to this, and find the intervals where f is increasing and where it is decreasing. Then find the relative maximum, minimum, and inflection points for f. Sketch the graph of f. So f of x is equal to x3 plus 2x squared minus 2. F of x is equal to x plus 3 plus 2x squared minus 2. Okay, so to answer a question of this kind, find the interval where it is increasing and decreasing. The first thing you do is you find the derivative of the function. So you differentiate, you get 3x squared plus 4x. Remember, the derivative of a constant is 0. After you differentiate, you equate the derivative to 0 and solve the equation. So you factor x, remaining 3x plus 4 is equal to 0, meaning x is either 0 or 3x plus 4 is 0. So x is minus 4 over 3. So from there, we now have, I have this, and I have that. What follows next is to go back to the function and differentiate it again. Okay, the derivative is here. So we differentiate the derivative. So we get 6x plus 4. From there, we come back to the numbers that we got and substitute them in the second derivative. So we have 6 times 0 plus 4, which is equal to 4, and 4 is bigger than 0. We also do the same to the other number, 4/3. That is 6 minus 4/3 plus 4, which is minus 8 plus 4, which is equal to minus 4, less than 0. Now the test says if the second derivative at the number c is greater than 0, it means that c yields a minimum point, a minimum value. 2, if the second derivative is less than 0, it means that c yields a maximum value. The question?
Yes, sir, sorry for disturbing. I wanted to ask what they mean if they say determine the nature of the critical point. What do they mean by that?
They want you to say whether they are maximum or minimum point.
Okay, thank you.
So I have a question.
Okay.
Are you recording the class or not?
I'm recording what you're saying.
No, okay, sir. All right.
So yeah,
Because I joined late, so I wanted to I never wanted to ask so that. Okay, sir.
Okay. So when so what we need now is to pick the numbers. So we have already picked the numbers and we have seen that 0, x is equal to 0, yields, according to the test, x is equal to 0, yields minimum. And x is equal to minus 4/3, yields maximum. What does it mean? It means that the interval of increasing, we say the increasing is increasing from where? Increasing from so when you go to minimum, it means that if you have a sketch, so we have x0 here, and then we have minus 4/3. So this 4/3 is maximum. So it means that going to the 0, which is minimum, then you go up. So there you go down. So it means that the function is decreasing from where it is maximum. I mean, the function is decreasing from minus infinity up to where it is maximum. To be increasing. So union, again, after decreasing, it will increase from 0 to infinity. And so it will decrease will decrease from minus 4/3 to 0. There it will decrease. Like that. So to check when you're sketching, if you are taking the line up like this, it means your graph is increasing. So when you reach there, you start coming down. Coming down means decreasing. Again, going up, this is increasing. So you check, you increase from -3 up to -4/3, decrease up to 0, increase up to infinity. So increasing, you don't pick the values of a function, you pick the values of x where the function is increasing. And then the other piece of this question says, let's look at it. It says, find the relative maxima, minima, and inflection points for f. So we have no inflection point. Then you sketch, and we have sketched the function.
Mr. Keith, what's an inflection point?
So an inflection point is a point where the function is not increasing and it's not decreasing, but it has a bump. Like it has some kind of shape that is very difficult to describe. For example, this function. Okay. So it looks like in this region, there's where it rested, but it did not change its nature. It kept on increasing. Those are points before points of inflection. Thanks. Okay. So it's just about when they ask you this type of a question, really what they're asking to do is to just find the first derivative, equate it to 0. Find the second derivative, substitute the zeros that you got there, have the function, and then do test in the second derivative. Like that. So the question it says find the relative maximum and the relative minimum. They mean now that we have said 0 yields a minimum, we should go in the original function and substitute 0. So we'll have 0 plus 0 minus 2, which is equal to -2. So this is the relative maximum. I mean minimum. Wait. You're confusing me. Very serious confusing me. Oh, the confusion is not on the it's not on the answer. The confusion is on it's on the graph, the word put it. Because the graph is supposed to be this is the turning point, so it will come like and then yeah, this is -2. So when you substitute there, we got -2. So this is the relative minimize. Oh, wonder. Then we also get -4/3. Substituting the function, so -4/3 power 3 plus 2 minus 4 over 3 power 2 minus 2. The answer you get here is the relative maximum. Like that.
So,
Hello.
yes, according to your statement, when you support differentiate the equation, you said when it is greater than 0, that's when it becomes a relative maximum.
When it's greater than 0, relative minimum.
Yes.
When
When it's
less,
greater than 0. Oh, okay.
so it's helpful.
So,
So I have a question.
Yes.
So meaning they can ask you to find the just the minima and the maxima, and also they can face the question in terms of relative, or it's just the same thing.
The same thing. So whether they say find the maximum or minimum, or find relative maximum or minimum, they mean the same thing. You find what is there.
I'm a bit
So what's the confusion?
because on the what's this on the minima just there you just wrote x is equals to 0 use that, and then also that one use that, and then when finding the relative minima you just found -2. So like how?
So we got the 0, which yields the minimum and substitute in the original function. If you put 0 there and you put 0, then you get -2. What?
Yes.
That's the -2 which you are calling relative minimum. It has been, because we are saying 0 will yield the minimum. So that's the one. It's -2.
Okay.
So,
You know.
how do you find the x-intercept where it is cutting the x-axis?
You equate the function to 0, the original function. That's like a normal polynomial.
excuse me, sir. Yes. So meaning that when you get the critical values, you replace them in this equation. So when you get a negative answer, does it mean that is it a relative maxima or minimum?
Which equation?
Like what you've done here, you said 0, then what? A -2.
No, listen. When I substitute in the original function, I cannot tell the nature. I will just find a number. The name of this number comes from when I get 0 and substitute in the second derivative. If the second derivative gives me a positive number, then the name of that -2 is relative minimum. If the second derivative gives us a negative number, then the name of the number you get here is called relative maximum. So the name and the nature comes from the answer you get from the second derivative. The first derivative gives you the critical numbers, the one that gives you the maximum or minimum. Then the initial function tells you the actual value. You see that? Let's go back to the question on it. Let's see. Differentiate from first principle. We did that, right? Do I have any here? Do I have any student here who claims or say that first principle is a very serious issue against their project? What's I'm impressed? Well, I don't know how you guys respond. You just keep quiet. So let's go to okay, these will be the domains. I found the domains. Is okay. I think the paper for 1120 is done. This one for last year. That means that if you guys have understood this paper, then you are 70% ready for the exam.
So I have a question.
Okay.
So when did you solve the entire paper?
In this of question 1 in the test that day. You remember the day we were doing sets? The intervals.
Yes.
They're the same ones as this one.
Also, you mean were just solving it half, but it was the entire paper.
Yeah, it was the entire paper.
Okay, so
Remember
I
that
thought maybe
there's the point where we solved it. To show that the number is irrational. And to make a
yeah.
number a fraction. And we had
Yes.
the complex number that we are adding and dividing. As we even had the hard one where we got the square root. We also had the binary. And that took us time that day.
Yes.
Then we had this question that I told you to finish.
Yes.
Then we have
So
this
maybe you
ratio.
should do a bit of revision on integration.
Days limited. We still have 3 days and then we mark 11. So there is tomorrow, there's Friday and Saturday. We're going to have so many classes. Since the exam has become very close. And the classes for these days will target match the 11-20 students. Then on Sunday, Monday, we target match the 11-10 students. And then after first, I will just remain with 1100 students. That's when we look at their exam paper. The exam paper for 11-10 was looked at on Sunday, Monday. We hope to finish it in those students. And also intensive divisions on those days. For 11-20, you prepare. You see this paper? It's quite very easy. But I'm going to, remember I said that I'm going to give you some questions. So I'm going to edit this paper and make my own. I also, where there are these gaps like here, we have matrices, which we didn't do this year. So I'll remove matrices.
Okay.
I'll remove matrices and put what we have done this year from the period sheet. It's another subject. I also put some nice interpretation also of the revising. And some nice identities. Since you hate identities. So that's the direction. So after so you just need to start going through this paper, go through test one, go through quiz one, go through test two, go through test two. Then we are set. Only 5 things, eh? Test one, quiz one. Test two, quiz two. Example last year. In all the courses, 1120, 1100, 1110. If you do this, the minimum thing you can do is not to do math next year because you are cleared it. Is that understood?
Yes, sir.
Alright. So whatever I don't understand, completing first basic, it should be understood at the appropriate time of the course. So if you're doing anything tomorrow, Friday, Saturday, you understand everything. We are giving
Mr. Keith, when are you giving us? Sorry, when are you giving us this question paper you set on your own?
on Friday.
Okay.
Don't start selling it as wicked then. You just be a normal paper and some questions. Last year people started selling my paper and said that I eat the exam. It's not true, right? Because and it looked true because most things were similar in the exam. So you can tell your sisters and your brothers who may not have managed to raise money for extra lesson in that. From tomorrow, it's for free. You can join. And because I don't have money, there's nothing you can do. So it's for free, eh? Tomorrow, after Saturday, the event, and for free for the event on Saturday, and Sunday, and 1100 also after days. Yeah. So let's keep all the different so enjoy this evening. And I update the timings. I know you guys are on study break, so there's no excuse as such. So I'll put proper timings before I sleep. And how we're going to proceed for exam preparation. I'll be putting time and topics.
Sir, I'm asking for the previous page for the application of Coursera.
Because it's about to come.